Hi, welcome. Mrs. Derby here with Algebra 1, Unit 1, lesson number 4. This is where we're talking about distribution shapes. So we have some examples of this in your workbook here in section 4.1, and it's just asking which one doesn't belong. So we can certainly play some games about, hey, which one of these doesn't belong with each other and why. What we're going to start seeing is that we want to put some vocabulary words with those descriptions. So let's take a look at some of our different values here, and we're going to go ahead and use some descriptions. I'm going to actually skip on down to my next slide because it's got the definitions already on that slide, and that way we can kind of see what it is that we're looking at, what kind of words we're going to use. So you may want to use these words right here, put them into your workbook because they're very, very helpful. And let's talk through what they mean. One way that we can describe a graph is to call it either symmetric or skewed. Okay, so these are two kinds of opposite kinds of things. If something is symmetrical, that means it's the same on the left and on the right. So a symmetrical graph is going to look a lot like graph A, our dot plot here on graph A. And so it looks like that. And so it's like if we draw this line right down the middle, the left side is like a mirror image of what's going on over here on the right side. So this is a symmetrical graph. B is also symmetrical. Again, if we put this kind of line right here in the middle, we have something that is going downward on the left, it's going upward, it's roughly the same on the left and on the right. And so that's what we've got going on there. And so B is also symmetrical, is what we would call that. What I also see, sorry, I was moving it so I can see my notes, is that C is also symmetrical. If we put a line right down the middle of the data set right here, the left side looks the same as the right side, mirror image. Okay, so with the symmetric graph, the mean and the median are right there in that line of symmetry. So where I've been putting these vertical lines here, that is going to be not only the average of our data set, but also if we counted into that middle number, we would also get to that exact same place. So the mean and the median are equal if our dot plot or our histogram or our box plot is symmetrical. Now we can also have a skewed distribution, and it's important to know that all of these can be from a dot plot or from a histogram or from a box plot. If we have something that's skewed, it means that our middle point, like if I counted all of these dots here in part D, this one is skewed. You see how it's got this kind of low part here to begin with, and then all of a sudden it peaks, and it's got a whole bunch of data over here, and then it's got this kind of tail over this direction. Okay, that means that the mean and the median are not equal to each other. The middle value would be somewhere around about here at -12, maybe -13. Okay, so if we counted to the middle number, I guess it would probably be around -13. That's where the median is. In this example, the median's there. This data over here, what it's doing is it's pulling the average to look lower than it would be if this was just where all of our data was. So it's pulling the average, the mean would be lower than the median. Okay, so our average is probably somewhere around about here because it's got these data points that are pulling that average lower than it really should be, than where most of the data is. So for that reason, we actually call D, not only is it skewed, but we get more specific about it, that this one is actually skewed to the left. So it's whichever direction that tail goes. So this one happens to be skewed left because it pulls the mean lower than the median. And we could have something that's skewed to the right. It would look like this, and it would have a whole bunch of data here and some data here on the right that's pulling that mean to look higher than it really should be, higher than the median. Okay, and we can do the same thing with like a box plot, right? If we had a box plot that was skewed to the right, we would see something like this that would have a normal kind of looking box plot, and then all of a sudden this gigantic long whisker, right? This long line over here. This one is very much skewed to the right. Okay, so it's got a chunk of data, a chunk of data, a chunk of data, and then this chunk of data that's all spread out, super long. This is a skewed box plot. A second way that we can go about it is to describe the actual shape of the graph. And so we have a couple different shapes here that we're going to use. And our shapes are going to use these three terms here. So if something is uniform, it means data values are relatively evenly distributed. This, part C, is a uniform graph. So C is an example of uniform. It's almost the same, and this one is exactly the same all the way across. If you wear a uniform for work, it means that everybody looks the same. So all of these data points look exactly the same. It's uniform. Now, another thing is that something can be bimodal. Now, that would be something like example B. A mode is what happens most often. It's the tallest bar of a histogram. It's the one that has the most number of dots on a dot plot. And you can see that this one has two modes to it. So a mode is what happens most often. Okay. This one has two modes. It's got one here and it's got another one here. Now A also has two modes, but you see how they're both right here in the middle? So it's got one value that's like the highest amount. It's like negative 14.5 or something like that. These are all the same height. This one has a highest point here. So in negative 12, it has the highest point. This one's got two of those highest points. And they don't always have to be on the outsides like this one is. We can have a graph that's kind of like M-shaped like that. And that means we also have two modes up at the tops. And then we have our ones like A that we're going to use the word bell-shaped to describe it. So bell-shaped is like graph A, our dot plot A going on there. If you draw a bell, a nice bell shape looks like that. And then it's got, that little clanger inside so that you can ring it. And that's what it looks like. So it's that mound with it's nice and symmetrical. It's got one peak in the middle of the graph, and everything else is kind of smoothly falling down the sides. So bell-shaped takes the form of a bell. Looking pretty good. So those are the words that we're going to look at to describe these kinds of things. We're going to use words that are symmetric or skewed. That's going to tell us what kind of data we want to use to describe it. And then we have uniform, bimodal, and bell. Now our next part that we're going to do in our workbook is not actually in the workbook. It's supposed to be like a card sort. Okay, so that card sort that's coming up next, 14.2, is about matching distributions. So I'm going to clear the ink off my screen, and we're going to actually go to Desmos and see what that card sort would look like. Okay, so I've got it here in Desmos, and I can't tell if you can still see me, so I'm going to just do that and move myself up here. This card sort is asking us to match each dot plot to the histogram that would be the same set of data. So if we had something like this one here, I'm going to start with this dot plot for no apparent reason. It's just right there. And I look at all my different kinds of graphs and things that are going on, my different data sets and things like that. Well, there are a couple things that I'm looking at. I'm having a hard time getting things out of the way. A couple of things that I would be looking at. I notice that they're all about the same. I notice that they go from negative 19 to negative 9. And that looks an awful lot like this histogram. Okay, so this histogram and that dot plot, and I cannot get them. Ugh. Sorry, there are times where I love Desmos and times where it just won't let it go. So that data set right here, this one we were looking at, would go with this dot plot. Okay, these two go together. And so it's because I can see them nice and uniform across the top. Okay, because I have those two together, I'm going to go ahead and just shrink those down so I've got some more space to work with. And now I also want to see what else is going on, what other kinds of data with things I have and what's going on. So roughly that shape that we have over the top is going to match what we're seeing in our dot plots and our histograms. So this one's got a big bunch of data, somewhere between 10 and 12, then it drops off drastically and then gets a little bit larger at 14 to 16. So I see that kind of happens here, where I've got a whole bunch of data here from 10 to 12, a little bit of data in the middle, and then it gets a little bit larger at the end. So I'm going to separate those two and put these two together, because that is the data, the dot plot, that would go with this histogram. Now on the flip side of that, this one has a very tall histogram bar on the right-hand side, and then a little bit shorter one on the left-hand side that looks a lot like this one right here. So those two go together. Meanwhile, this one, bimodal, remember that word, so it's kind of got that U-shaped look going on. This one also has that U-shaped look to the data, and we haven't used this dot plot yet, so this one's going to go over here with this guy. Now these last ones look very similar. They're both very bell-shaped. Notice that these two histograms look very similar as far as height. The only thing that makes them different is the data values at the bottom. So this one goes from -19 to -7. This data set goes -19 to -7. Those two have to go together. This one goes from 1 to 13. That has to go here. So we've got these matches of data sets that go with each histogram, and that makes sense. Now on the next section, it's going to ask me to sort it into 3 categories: which ones are skewed, which ones are symmetric, and which ones are kind of in the middle there, right? Because there's no like rule that's hard and fast rule that's going to help us know skewed from symmetric. Okay, so I'm going to put all my symmetric ones over here. I'm going to do that. So when I see that, so I'm going to have my skewed over here on the left-hand side, my symmetrical ones on the right, and I'll put my unsure in the middle. Okay, so this one is very much symmetrical. This one is also very symmetrical. This one looks pretty symmetrical, right? I've got 2 dots, 3, 4, 3, 2, 2, 1. So each of these are very symmetrical. And then, of course, we have the graphs that go with those. So I'm going to go ahead and put all 3 of these ones all together. It's kind of funny. There we go. They just go here. So that's my symmetrical looking ones. When I look at each of my dot plots, I'm just doing the same thing. This one looks very symmetrical. I can draw a line right in the middle. It's the same on the left and the right. That guy's symmetrical. This one's skewed. It's got a big mound over here, and then it kind of tapers off down on this way. So this one is skewed to the left. That one's uniform. That's very symmetrical. Sorry, I'm looking at dot plots. Stay with the dot plots. These two are looking very skewed. Okay, so it's got a tall one, and then it tapers down. This has got a tall one and taper down. And then I'm just thinking about how we already matched them over here with the histograms and the dot plots. This is a skewed histogram. It's a lot of data here. This is going to pull the average to a weird place. Same thing going on there. Symmetrical, symmetrical. So yeah, I really don't need that unsure pile. They let me have an unsure pile, but I don't really need it. Like all of these over here are looking really symmetrical. Everything over here is looking really skewed. All right, there you go. That's our stuff for lesson 4.